Here comes a chi-squared test done in SPSS. More specifically, this is a chi-squared test of independence as opposed to a chi-squared goodness of fit test. Okay, they are very similar, but the test of independence, normally your variables are independent of each other, so that's what we're going to do. So let's pull up SPSS, and I'm going to talk about the assumptions real quick. The assumptions are that your people in the study should be from a simple random sample. Your sample size should be a minimum of 5 per cell. And again, we're expecting that the variables are independent of each other. So here comes our chi-squared test of independence. We go to Analyze, Descriptive Statistics. The computer calls it crosstabs. Okay, be careful. There's another function under the non-parametric list that has chi-squared, but that is a different kind of chi-squared. I'm not 100% sure. For this chi-squared, we're going to use crosstabs, and our variables that we're comparing, make sure they are clicked as nominal, is going to be ethnicity versus political party. Doesn't matter which goes into which. Statistics, we want the chi-squared, of course. We want the Kramer's V and the phi coefficient. That's going to give us our effect size and the strength of the relationship. And the rest of this stuff, I don't think we need anything. Cells, personally, I always like to see the expected count. That is, if the null were true, that would tell you how many people should be in that specific cell. We're going to click Continue. Format, I don't think we need anything there. And let's click OK. And here is the output. I'm going to go ahead and switch over to a different version. Please hold. Okay, here's the output. According to this, the chi-squared was 25.57, and it was significant, right? Less than 0.05. So that means that there was some kind of relationship between a person's ethnicity and which political party they belong to, okay? The next thing we want to look at is, this is the degrees of freedom, 12. That's the number of groups for ethnicity, -1, times the number of groups in the political party, -1. So we had 5 for ethnicity, so 5 minus 1 is 4, times we had 4 for political party, so 4 minus 1 is 3, so 4 times 3 is 12. All right, and our phi coefficient is simply your chi-squared test statistic, 25.575, divided by the sample size. Whatever that number is, you're going to take the square root of it, and that is your phi coefficient. So that's like a correlation. So 0.379 is actually pretty strong for a correlation. So that means you do have some kind of significant relationship going on between political party and ethnicity. And it was significant, right? It was less than 0.05. So the Kramer's V is 0.219, and we think of that like as effect size. It too was significant. So roughly 22% of the variation between the relationships between ethnicity and political party can be explained by this model. So what I always do is I look for the actual difference between the groups there. So here is the count that was the real data, the observed data, and here's the expected count if the null were true. So what I'm looking at is any significant difference between the actual count and the expected count. This one is pretty big. It's about 8, 5, 7, 2, not big of a deal here. Going down to Latinos, 9 and 11, 7. Now they're all pretty close. Again, I'm comparing the counts to the expected counts. This one's a little bit different. It's about 4. So the only major differences I'm seeing is between the white voters, right? 9, 5, 10. So that seems to be the key here. So let me see how I wrote this up. Okay, so according to the output, there was a significant relationship between ethnicity and political party. The chi-squared of 12 degrees of freedom was about 25.57, and it was significant. The overall results indicated that white people tended to be in the Democratic Party, right? While the Latinos and African Americans and everybody else tended to be in the Independent Party. So let me check that Independent Party again here. Yep, there's a difference of 3, 7. Yeah, that's about right. But that's it. I hope this helped. MGZ.